Now let's solve this GATE 2014 question. So given reference string is 1 2 3 4 2 1 5 3 2 4 6 and number of frames are given as 3. Let's see what happens with the optimal, LRU and FIFO. So first of all, if you look at this, how many different pages are, it is demand paging, which means nothing is there in the frames as of now. So if you watch this, how many different pages are completely referred throughout the lifespan of this program. Let us say this is the complete reference string. Then how many different pages are referred? 1 2 3 4 5 6. So 6 pages have been referred, and out of which some are repeated, right? So whenever you are referring 6, then the page fault should be at least 6 in case of demand paging. Why? Because you have to get them into the main memory at least one time, and whenever they are being referred for the first time, that will be a page fault. Therefore the page fault will be minimum 6, whatever algorithm you use, either you use LRU or whatever, it is going to be 6. So even optimal should also give you 6, and then optimal will try to optimize in this sense. You know, if some page is going to be referred again, then it will try to conserve it, it will try to protect it in the main memory without replacing it. That is how optimal is going to be helpful. Okay, now watch it. So now 1 is referred, so 1 is not there, so got it. 2 is referred, 2 is not there, got it. 3 is referred, 3 is not there, got it. Now we want 4. So when we are trying to replace something for 4, which will be the candidate for this replacement? Now 2 is again required, 1 is again required, but 3 is required at a very far distance. Therefore 3 is the victim now. 3 will be replaced with 4. Next 4 is done. Next 2 has to be, 2 is referred, 2 is there. 1 is referred, 1 is there. Now next 5, we want 5. Now if you want to get the 5, if you see this, 3 is okay. 1, 2 and 4 are there. Which one you want to replace? 2 and 4 are required, but 1 is never required. Therefore you can replace 1 with 5, right? Fine. And next you need 3. 3 is not there. Which one do you want to replace? So other than 4, 2 and 5 are never okay. We want 3, right? Yes. Now we want 3. So 2 and 4 are required, but 5 is not required. Therefore 3 will be got here. Next we want 2. So 2 is already there. 4 is already there. Next we want 6. So you can replace anything and you can get 6, right? So how many page faults are there? So if you watch the number of page faults, the page faults are going to be 1 2 3 4 5 6 7. So 7 are the page faults by optimal, isn't it? So it will get at least 6 because there are 6 different pages which are being referred. Therefore above 6 we got 1, which means we got 7 page faults. Now let's see how does this LRU work, least recently used. So number of frames are always 3 here. Number of frames are 3 and the least recently used I am going to use. So 1 is referred, 1 is loaded, 2 is loaded, 3 is loaded, and now when we want 4, right? So which one are you going to replace? So if you watch the history, then 3 is most recently used, 2 is next most recently used, but 1 is least recently used. Therefore we are going to replace the least recent used 1. That is why we got replaced this. And next 2 is required, 2 is there, 1 is not there. Now in order to get 1, so look at the history. So we are talking about 1, right? Not to get 1, look at the history. 2 is least recently used, 4 is least recent, most recently used, and 3 is the least recently used. Therefore it will be replaced, right? And next I am looking at 5. Now 1 is most recently used, 2 is most recently used, and 4 is the least recently used. Therefore this one, right? And now I am looking at 3. So 5 is most recent, 1 is most recent, 2 is the victim. And now I am looking at 2. So 3 is most recently used, 5 is most recently used, and 1. Therefore 1 is going to be replaced with 2, right? And then I am looking at 4. So 2 is most recently used, 3. Therefore 5 is the victim. And then I am looking at 6. So 4 is most recently used, 2 is most recently used, therefore 3. So how many? 1 2 3 4 5 6 7 8 9 10. So this LRU is going to create, how many did I say? 1 2 3 4 5 6 4 plus 3 7 10. So 10 are the misses, right? So 6 is the minimum, and above that it got 4 more. And let's talk about FIFO now, first in first out. Okay, so now we need 3, 1 2 3, so 1 and then 2 and then 3, they will be loaded. So the queue contains 1 2 3, and next I need 4, therefore 1 will be replaced and 4 will be added. And next I need 2, 2 is already there, and next I need 1, therefore 2 will be replaced and 1 will be added, right? And next I need 5, therefore 3 will be replaced and 5 will be added. Next I need 3, 3 is not there, therefore 4 will be replaced and 3 will be added. And next I need 2, therefore 1 will be replaced and 2 will be added. Next I need 4, therefore 5 will be replaced and 4 will be added. Next I need 6, therefore 3 will be replaced and 6 will be added, right? Now how many are there? I think this is also going to give you 10 replacements. See, I think you understood the concept, right? Maybe while solving these questions I might have gone wrong somewhere because I was just trying to do it fast. So in case if you feel that I'm wrong anywhere, you please use your intuition and your good judgment and find it out, okay? So there are chances that I might go wrong somewhere, but anyway you understood the concept, right? So if you understand the concept, we can do more questions. Fine.